On the left, we have dirt. On the right, we have soil. One of these things is the giver of life and is extremely important to all life on Earth. The other one is a bunch of small pieces of rocks. Don't forget that red slides are where you have to take notes. You should have your notes handout ready to go. Don't forget to look for the owl and let me know where he is. And remember to fill in all of this stuff that you see here. Okay, so what exactly is the difference between soil and dirt? Well, soil is weathered rock. It is humus, not hummus, by the way. Hummus is a different thing. That's something you eat. This is not something you eat. Humus is a dark-colored decayed remains of plants and animals. This is the organic material. This is all the little bits and pieces of tree leaves and cut grass and all of that kind of stuff that kind of sits on the top of the ground and decays. This is hugely important. This is the part that feeds the plants. This is the nutrients. This is what makes the soil healthy. And finally, it's all the plants and animals and fungus and bacteria and bugs and things like that, that all of the living things that actually live in this ecosystem. It is one of the biggest and most diverse ecosystems on the planet. And so it's a really important ecosystem, and it is all those little critters that basically turn the leaves and dead grass and stuff like that into the organic matter, into the nutrients, into the humus that the plants need to grow. And check out this little video clip that will explain that a little bit more.
Hi Al, I wanted to talk to you about how soil is made. Now we spoke before about how rocks erode to kind of create soil, and what you get is kind of a sand kind of thing like this. But that's not what we really think about as soil. What's missing there is something else. Take a look at this. Now this is nice, good black dirt. The difference is, besides the little pieces of rock and sand that's there, there's also organic matter. Organic matter is anything living or that came from something living. So for example, a leaf. Now this is a dead leaf that's fallen. Eventually this gets broken down and becomes a part of, mixes with the sand and becomes part of this darker soil. So as it gets broken down, it might start to look like this, and then the pieces get so small you can't even tell they're there anymore. So how does a leaf go from something like this to that? Well, it needs some help. One of the things that does it is bacteria. Bacteria eats away at the organic matter and breaks it down into very, very small pieces. But even before bacteria get started, there's organisms called detritivores. Now we'll talk later about why they're called that, but here's some examples. Here's a detritivore. What he does is he's got a really tiny mouth, and at night he comes up and eats at the leaf and any other dead grass, things like that, and eventually it looks like this. But you know, whatever goes in this end has to come out this end, and those small particles become a part of the soil or get broken down by bacteria and become a part of the soil. Another example of a detritivore is something like this. Now this is a giant cockroach, not something that you normally see around here, but he's an example of the types of beetles and bugs and millipedes that eat dead organic matter, cause it to break down, and then become a part of soil. Hope that helps, Al.
Now, in comparison, dirt is pretty simple. Dirt is mineral-based, and it's pebbles and finely ground rock. So more or less, this is small bits of rock. That's what dirt is. Soil has the very important added ingredient of the humus, the organic material, which is basically where all the life comes from. Dirt is dead, soil is living. Big difference. So what does healthy soil look like? We should get a sense here of what it looks like when you take a look at it. Color is going to be really, really important to the understanding the health of the soil. So if the soil is black, that means it has lots of organic matter in it. Organic matter mostly is made of carbon, and carbon is like charcoal. It's like the graphite that's in your pencil. It's mostly a very dark black kind of color. It may be poorly drained if it's black. That might not be a good thing. And it's usually pretty fertile. So black soil isn't bad, but it's maybe not the best. Brown soil has lots of sand and clay in it. It is well drained. This is the perfect kind of soil you want. You want something that's sort of in between the brown and the black. You want a nice, dark, rich, dark brown soil. If it's very light brown or white or orange or red or yellow or things like this, this is not good. This means we have a lot of compounds like iron and manganese and sulfur. These things are all bad news for plants. There's probably too much salt in here, and it's not really that healthy. This is not really a good growing environment for plants. We really want that dark brown color. If you see red soil, this is kind of interesting. Basically, the red soil means that there's a lot of iron in that soil, which is not necessarily a good or a bad thing, but this is what turns it red. The soil is literally rusting. So, layers of soil horizons. Basically, as you go down into the soil, as you dig down into the soil, you can see very distinct layers in the soil. So we need to talk about that. So this is what a typical soil profile will look like. So please fill in your diagram in your notes. First of all, we have the very top horizon, and I get the sense that this was kind of added in as an afterthought, but this is what they call the O horizon, and you'll see what I mean by that in a second. This is where the organic matter is. This is basically the leaves and chopped up grass and things like that, and all that stuff that is just sitting on top of the ground that you are walking on. Then you have the A layer, and this is what we call the topsoil. This is where all of that stuff has been decomposed, as you saw in that little video clip, and has been kind of put back into the ground and mixed in with the dirt and has turned the dirt into soil. We talked a lot about the topsoil layer. This layer is really important. This is where the plants really get most of their nutrients from, and so we talked about this in terms of erosion. This is the first thing to go when erosion happens, and so this is a really important layer, and so when that gets eroded away, it's very hard to have any sort of plants growing in there. Then you have your B layer, which is called subsoil. This is where we're getting mostly into clay. This is sort of very hard, packed together material, kind of hard for plants to grow in this, and there's not a whole lot of organic material going on in there. Then we have the C layer. This is called the parent material. It's called the parent material because this is kind of where the dirt comes from. This is where we start getting into what you would think of as broken up pieces of rocks. And last but not least, we have the bedrock, which is the original solid rock that has not been broken down into smaller pieces yet. Another very, very important concept when we talk about soil is the particle size. This is important for a couple of reasons because it determines a lot of the characteristics of the soil and in terms of how easy it is to grow things on the soil, how well the soil drains, whether or not you can build buildings on the soil. All sorts of things like that are dictated by the particle size. But as we've talked about quite a bit in terms of sedimentary rocks and things like that, it also tells us a story. Different types of sediment are going to be laid down in different types of environments. Think of a beach versus a swamp or something like that. You're going to have very different types of sediment going on there, or a mountain versus a desert or something like that. Different types of sediment there, and so as we look through these layers of sediment in the rock record, we can really tell a lot about the history of that area. So, soil particle size affects the types of plants that will grow, affects how well water will drain, and how the soil packs together, and how the soil settles in water. That's an important part too. So, particle sizes. Take a look at this. This is kind of an enlarged kind of thing. You can see that this is a scale of millimeters. So right here is a blown up millimeter. Remember, millimeters are really like that big. They're tiny. They're little tiny things. They are the smallest lines on a meter stick. So this is really magnified. This is much bigger. So these guys right here are only a little bit over a millimeter in their diameter. And you can see that these guys over here, even on this scale, are really, really tiny. So the first one is gravel. Make sure you're filling these in your notes. Gravel looks like that, 2 millimeters to 75 millimeters. The next one is sand. Sand looks like that, about 2 millimeters. Here is some smaller sand of 1 millimeter. Sand comes in different sizes. There's a range. And we have fine sand, which is like 0.5 millimeter. There's a view of some fine sand under a microscope. And then we have silt, which is smaller than sand. This is, again, under a microscope. This is something you would not be able to see the particles very well with the naked eye. Silt looks like that. And again, it would be laid down in these kind of areas, like a swamp or a floodplain of a river or a pond or something like that. Looks like that when it dries out. You can see that you really can't see the size of the sediment here. They're really pretty small, but they're not the smallest because clay is the smallest. And this is what clay looks like under a microscope, very, very small. This is what clay looks like not under a microscope. And yes, when we say clay, we mean that kind of clay, the kind of clay that you make pots out of and dishes and things like that. That's where that stuff comes from. You dig it up from the ground. It's basically dirt with very small sediment size. That's what your plates are made out of. There you go. Yeah, never thought your plates were made out of dirt, did you? That's kind of what a handful of it looks like. We get a lot of that around this area. You find a lot of clay when you dig down into the soil around here. There's another picture of some clay. All right, so the next thing we need to talk about is this picture here and this idea that the sediment size affects how water can travel through it. So I want you to look at these pictures and notice that if you have something like gravel, which has large sediments, when you put them all together, you can imagine that there's a lot of holes in between these sediments, right? Like here, and all these little pathways for the water to kind of trickle through here. So the water gets through pretty easily with these larger sediments. Finer sediment, as we get finer and finer, the sediments tend to pack together more and you don't get as many spaces in between, so the water has a harder time getting through here. So this water is going to take a little bit longer. It's going to be a little bit slower to get through. This water is really going to have a hard time to get through. In some cases, it could take literally centuries for water to seep all the way through this and get down to the bedrock. So what we're talking about here has to do with two words: permeability, which is the rate at which water and air move through the soil. This is how easily the water flows through the soil, or how easily it permeates the soil. And that has a lot to do with the porosity of the soil. And if you think of the idea of the pores that you have in your skin, well, those are the little holes, right? So porosity is the spaces that allow air and water to move through. These are the holes in between the sediments. So this would be low porosity. This would be high porosity. Porosity and permeability kind of go together. The more porous a material is, the more the water can flow through it, so the more permeable it is. Generally speaking, there are some exceptions to that. There are some cases where you might have really big holes in the rock sediment, but those holes aren't very well connected to each other, so you can have a high amount of porosity but a low amount of permeability. But that's kind of a rare case. Usually the more porous something is, the more holes, the more space between the sediments, the more permeable it is, the more it allows the water to flow through it. One of the important factors of this is the kind of thing that happens when you do not have good porosity and permeability. The water tends to sit on top of the soil and doesn't really sink down into it. And this is important for the reason of the picture that you see here, but it's also important when we talk about farms and things like that and growing crops, because if the water is just sitting on top of the soil, it doesn't really get down into the soil where the plants need it. All right, so this week we will be continuing to talk about soil. We've been talking about soil erosion lately, so now we're going to talk a little bit more about the characteristics of soil. As I've told you many times so far, this is a very, very important topic. I understand, I know, dirt, stuff like that doesn't seem like that important, but it really is. This is the idea, the studying of soil, the understanding of soil and how it works and how to use it to grow crops and things like that is something that affects the entire world population and affects it in very serious life or death kind of ways. So this is something that we kind of all need to know about and all need to be able to work together to help preserve soil, whether it's in your backyard or whether it's on a farm or whether it's people going out, like some of the people that we've seen that go out to different countries and try to help them change their country from a desert into something where they can grow crops and have food for their families. So soil is weathered rock, that all-important humus and living organisms that live in there and create that humus. Dirt is, well, it's just rocks. That's it. Not quite as important to human life, although still interesting, still very important as far as us understanding the history of the earth and things like that. But when it comes to human life, it's all about, and all life on earth, not just human life, it's all about the humus. It's all about the soil. Soil color is a very good indicator of the health. We really want that dark brown soil. That's what we're looking for. This week we will be making some soil to grow plants in, so try to keep that in mind. Soil horizons are the layers of the soil. We'll be looking into that. We'll be trying to sort of going outside and looking at the different layers of the soil. Particle size is very important, and this affects the life of the plants. This affects the drainage. This affects the packing of the soil. It affects a lot of things about the soil, what you can grow there, what you can build there, how well it will drain when the rain comes, and things like that. Permeability and porosity relate to the amount of space between the sediment and how water flows through it. And again, very important for your community, your neighborhood, as well as growing crops and all that kind of stuff. All of these things are things that we need to know about, and we will talk about them in great detail this week in class, and I will see you then.